Today is November 19th. This is period 2. And today we are doing sum and difference of cubes. So these are two methods additional to factoring polynomials with two terms. So last week we did the difference of squares, and that was for polynomials with two terms. Today we're doing two more methods that both work with polynomials with two terms. So on your page with all of the factoring methods, we need to find where we've got the difference of squares, and that was for polynomials with two terms. And we've got to tack on this red stuff, because there are two more formulas that work for polynomials with two terms. So you're adding or the difference of cubes or the sum of cubes to that line where we've got two terms. Right, you're writing what's in red, yes. And then I want you to write down these two formulas, please. Today we're doing sum and difference of two cubes. So, what is a perfect cube? 4 is a perfect square, but I'm glad you said that, because it kind of helps to expand our yes. It helps us to expand our thinking. 8 is a perfect cube. Why is it a perfect cube? Because 2 times 2 times 2 is 8. So if you multiply some number by itself 3 times, you get a perfect cube. Okay? So this method works only if we've got both terms are perfect cubes. And then there's two formulas, one for the sum of two cubes, one for the difference of two cubes. So both of these are the sum of two cubes. Our first job is to figure out what is the cubic root of each term. So what number can you multiply by itself 3 times that gives you an x cubed? X, right. So we're going to say, oops, let me get that formula that I need. This is the sum of two cubes, so I'm taking this formula. And I'm going to paste that right here. So here's the formula that I'm using. Okay, in order to use the formula, you need the cubic root of both terms. So I asked the question, what do you multiply by itself 3 times that gives me x cubed? And Fraziani answered x. So A is x. Why? Because x times x times x is x cubed. How about 64? What is the cubic root of 64? 4. Excellent. Who wants to be my calculator today? Christine has a calculator. Christine, would you be my calculator today? Okay. So I want to show you that you can do cubic roots on the calculator. All right, and then Christine is going to be our calculator for the rest of the day after I show everybody. Okay. So if you hit the math button is right here. Okay, it's on the left-hand side. If you hit math button, which of these choices says perfect cube? Or cubic root, I should say.
3.
It's not 3. Try again. Which of these is the cubic root? 4. Choice 4 has a 3 and then the radical sign. So that's the cubic root. So I'm going to do the cubic root. I chose option 4 of 64. Press enter. The cubic root of 64 is 4. Why is that true? That's true because 4 times 4 times 4 equals 64. Okay? So that's how you use the calculator to find the perfect cube. Or the cubic root. Alright. Now that we know the cubic root of both terms, we are going to just plug those things in to this formula right here. Okay? So I've got a plus b, so that would be x plus 4 times, and then I have a squared, so that's going to be x squared minus a times b, so that would be x times 4 plus b squared, so that's 4 squared. Now I have to put it into a simpler form.
Is that a minus 4, or is that x squared minus x?
Yes, because of this subtract right here in the formula.
What's after like x minus 4 times
That's times, because a times b, so I've got x times 4. Now I'm going to put it in a simpler form. Okay, the first parentheses is already the simplest form possible. But over here, x squared is fine, but when I write x times 4, that's usually written negative 4x. And then 4 squared is 16. Now, I usually would skip the first line, and I would do all of that in my head. But the first time I did this, I just wanted to write it out to show you how are you getting that. I think this is one of those situations when you write too much stuff out, it just confuses the matter. I think if you're perfectly capable of doing this in your head. So here's my next one.
Holy shoot.
So we are looking for the cubic root of 125 n cubed. So Christine, what? Doug wants to use the bathroom. It's on YouTube now. Go ahead, Doug.
Come up, Doug. Do it.
Christine is going to find us the cubic root of 125. 5. So A is 5n. And then she's going to find the cubic root of 216. 6. So B is 6. Alright, so here's my formula. And I've got, now I'm going to skip that first step this time. I'm going to do that in my head. So I've got A is 5n, so I've got 5n plus 6. And then the second parentheses is A squared. So I'm going to square 5n. So 5n squared is 25n squared. Minus. And then I've got A times B. So that's 5n times 6. That would make 30n. And then I've got B squared, which is 6 squared. So that's 36.
Hey, Miss.
Yes.
So in the first problem we did, why didn't we square 4?
We did in the second step.
Oh yeah, the second time. Okay.
So in the first problem, I wrote out a step that I didn't do in problem 2. I think it's easier to do that in your head than to write that out. That's my opinion. If you think it's easier for you to write that step out, that's fine. Okay? I'm going to move on.
Then.
All right, so this one is a difference. Write down the problem. We've got a different formula for sum and a different formula for difference. So I'm going to go back and find my difference of 2 cubes formula. Oops, here it is right here. Here's my difference of 2 cubes formula. I'm going to copy that, and I'm going to bring it to my new page. So what's the cubic root of y to the third? y. What's the cubic root of 64? 4. We already did cubic root of 64, so we should do that. So now I'm going to plug that into my formula. So I have y minus 4, and then a squared is y squared, plus a times b is y times 4, that's 4y. And then b squared is 4 squared, that's 16. We good?
No.
No? All right, 2 more problems. Guys, what do you always do first? GCF. Write down problem 4, and then see if you can tell me what is the GCF for problem 4. Francie's getting extra credit, thank you. All right, further, I'm sorry I hit pause. So what I just did was I GCF'd a 2z to the second out. You always GCF first. All right, so inside the parentheses, I've got a z to the power of 3. That clues me in. This might be the difference of 2 cubes. So what's the cubic root of 8z to the third? You should know that by now. What's the cubic 2? Good, so I've got 2z. What's the cubic root of 125? I don't think we've done that one yet, have we? Christine's going to do that for me.
5.
It's 5, yes. You got B, Christine, sorry. B is 5. So I'm going to bring down my 2z squared. And then I'm going to use my formula for the difference of 2 cubes. So a squared is 2z squared. That makes 4z squared. Oh, hold on, I'm messing up. Everybody stop me here. The first parentheses just has a minus b. So this is going to be 2z minus 5. Sorry about that. The first parentheses just has a minus b. The second parentheses is where we're going to square it. So 2z squared is 4z squared. And then plus. And we're going to multiply a times b. That's 2z times 5 makes 10z. And then plus b squared is 5 squared. That's 25. So my GCF is negative 5. Negative 5 is z to the third divided by negative 5 is z to the third. Just a reminder, anytime the first term is negative, the GCF is negative. 320 divided by negative 5. Oh, I don't know if I can do that in my head. I'm running out of time. You can do it. What is it? What is it? You guys did it already, right? Yeah. 320 divided by, what is it? 64. Okay. So A is Z, B is 4. Bringing down negative 5. I've got Z plus 4 times Z squared minus 4Z plus 16. Oh! And I've got 30 seconds to spare.
Oh, gee. What was that?
Oh, I got 30 seconds to spare. Do you have questions on that?
Nah, we good.
Good job.
Make sure you slash that like button. Follow me on Instagram. It's your boy, Steve Chicken.